So quick review, we've been talking about how to translate parent functions. We did the list of parent functions, and then we talked about how to reflect them over the y-axis, over the x-axis, how to move them vertically up and down, and how to move them horizontally left and right, correct?
Yep.
Okay, so now we're going to talk about applying a vertical shrink or stretch to it. So again, we had our parent function y equals f of x. And a is going to be a positive number. If you look at the graph of y equals a times f of x, if a is a number that is bigger than 1, and you do a times f of x, you vertically stretch the graph. Okay? You vertically stretch the graph. If you know that the point xy is on the parent function, then the point a times y is on the new function a times f of x. If I were taking these notes, I would say if a is bigger than 1, you stretch it vertically. If a is between 0 and 1, you're going to shrink it vertically. And we're going to go do 2 examples and you're going to see. Okay, example number 1. Go graph y equals 3 times x squared. What is the parent function? Y equals x squared right here. That's the parent function in red. You all know from the other day the points for y equal x squared should be negative 1, 1, 0, 0, and 1, 1. You know that, right? Negative 1, 1, 0, 0, and 1, 1. The parent function looks like this. And you all did it with your arms just now, correct? Uh-huh. Okay, that's the parent function. We're wanting to graph y equals 3 times x squared. All you're going to do is multiply all of your y values by 3 on your parent graph. So this becomes 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3. You now have the point negative 1, 3, 0, 0, and 1, 3. All you did was basically pick up the ends of your parent function. You grabbed them with your fingertips and you stretched it up. Why did you stretch it? It's because the number that was out front was bigger than 1. And then, like someone so generously pointed out the other day, if you can't remember all the parent functions and all that kind of good stuff, what can you always go do? You go over to your y equals. Our parent function is in red. We're going to put just x squared in the red. And in our blue function, we're going to put in 3x squared. And my window. Okay, there's 3x squared. There's x squared. Question for you. That was a vertical stretch because the number out front was bigger than 1. Vertical shrink or vertical compression, say y equals 1/3 x squared. What do you think it's going to do? Go type it in on your calculator. Let's go do in green. Let's go do 1/3 times x squared. What'd it do? Here's x squared. What's 1/3 going to do to it? It's going to make it wider. Exactly. Okay, so I'm going to go ahead and do, this is at 1/3. Here's y equals 1/3 x squared. If the number out front is bigger than 1, you grab the ends of the parent function and you stretch it up. If the number out front is smaller, is between 0 and 1, you're going to grab the ends and shrink it. You're going to compress it down and opens it up. Questions there? Go do number 2. Y equals 1/2 x cubed. Okay, for the example, y equal 1/2 x cubed, I'm going to go do the calculator first this time. Under your y equals, in the blue, we want to do 1/2 x cubed. So 1/2 x. There is a cube button, but I think it's easier just to do the caret, which is above the division sign, and say raised to the 3rd power. And then in the red, I'm going to put just x cubed. Again, to get to the power, you're going to push the little caret button that's above the division sign. Okay, there's my 1/3 x cubed. There's my x cubed. I'm going to play with the window just a little to get rid of some of those x's and spread it out. There's my 1/3 x cubed. There's my x cubed. So do you see where you take the red one? And it was 1/3, so it was less than 1. I'm going to shrink it back down to the x-axis. So it's going to squish it and make it wider. We're going to go graph, let's say 5x cubed. So if this is the parent, I'm doing it backwards to you guys. If this is the parent graph, what are you going to do for 5x cubed? You're going to stretch it, and it's going to get closer to the y-axis. It's going to do 5x cubed. You see how you stretched it out? Okay, to go plot everything, we have -1, 1, -1, 0, 0, and 1, 1. -1, -1, 0, 0, 1, 1. So my x cubed graph looks like that. 1/2 x cubed, I'm going to go multiply all my y values here by 1/2. So I get -1/2, 0, and 1/2. Do you see that the point is -1, comma, -1/2? That's the point on my graph, which would correspond to right here. And then this is the point 0, 0 on my graph, which is here. And then I have the point 1, 1/2 on my graph. So my function looks like this. It's a little wider. It's been vertically compressed or vertically shrunk. If I wanted to graph, say, y equals 2x cubed, here's my parent function. So I'm going to erase these. No, I won't. I'll go do it over here. Here are my y values. I need to multiply all of those by 2. So I get -2, 0, and 2. My points become -1, -2, 0, 0, and 1, 2. There's y equal 2x cubed. It was vertically stretched. Okay, if you want to use your calculator and find points on your graphs, you go to second table. It's above the trace button. No. Second. table. It's above the graph button. And those are your points. I need to go to table set. I'm going to go by 1, 1, auto. There we go. I have on my parent graph -1, -1. It's in red. On my graph of y equal 1/2 x cubed, I have -1, -1/2. Got it? So it's under second graph, it's under your table to get to your points.